Hello students. In this class we will see the topic real numbers. It is the first chapter in the high school. What are real numbers? Let's brief about the number system before we start the real numbers. We know the number system starts with natural number, right? Which is denoted by n, and the natural numbers are always countable numbers. Means they start with 1, 2, 3, 3, and infinite natural numbers. Countable numbers are natural numbers. Whole numbers is the next set of numbers where they're nothing but natural numbers but includes zero as well, because natural number doesn't contain zero because we cannot count zero. Nobody says I have 0 rupees, I have 0 houses, but there's a possibility that I got 0 marks, but that's not countable, right? So whole number starts with 0, 1, 2, 3. Then we get integers. Integers means they are negative numbers, also include 0, also positive number, and there are infinite negative numbers, infinite positive numbers. So all here again we get two sets. Positive integers means 0, 1, 2, 3, all positive numbers. Negative integers, that is -3, -2, -1, 0. Okay. 0 is neither positive nor negative. I'm sorry, I don't write these things here. Okay. This integers is also represented with letter z. So z plus or z minus. Now next we have rational numbers. We have seen rational numbers. Is q represented with letter q? P by q is a rational number where p and q belongs to integers and q not equal to 0. This is a simple definition of rational numbers. For example, any fractions you take, they are all natural numbers. Rational numbers. We saw in the ninth standard the other definition also, like rational numbers are non-terminating. That is not required now, just I am recapping it. Non-terminating, recurring, decimal, expansion. This is one type of definition. They are non-terminating. For example, 1.33333, it's a rational number only. The digits are recurring, but the expansion, decimal expansion, is non-terminating. The other definition for rational number is terminating, decimal expansion. I'm just recapping it before we touch upon the real number topic. Terminating means, for example, 1 by 3 we get 0.3333. Sorry, it's a sorry, not terminate. It's a terminating means we say 2 by 5. So 2 by 5 means 0.4. So it's again a rational number. This then the rational, not irrational numbers. We saw this in the ninth standard. Irrational number, they are not in the form, not in form p by q. Okay. Or with respect to decimal expansion also, we have a definition for irrational numbers. These are irrational numbers. These are rational, or it is whose decimal expansion is non-terminating and non-recurring. Non-recurring or repeating, both same. So for example, if you want to give example for a irrational number, we can say 1.53533 dash dash dash. See here, the decimal expansion is non-terminating, and also it is non-repeating. See the sets of the digits, they're not repeating here. That's a irrational number. Let's go to real numbers. So real number, what do you mean by real numbers? Real numbers means it is set of both rational and irrational number together. Okay. So real numbers. For example, any number you tell that will be part of real number only. For example, I say root 2 is a real number, 5 by 3 is a real number, root 5 is a real number, 6 by 17 is a real number. Okay. This as a whole, all the numbers we use come under real numbers. Okay. Let's move on to the next topic. Prime number. We know what is prime number already. We have learned this in earlier classes. Prime number is a number which has only two factors. What are the facts? 1 and itself. For example, can we say 3 is a prime number? Yes, it has factors 3 and 1. Only two factors, right? Can we say 4? No, because it has 1 is a factor, 2 is a factor, 4 itself is a factor. So it comes 3 factors. So not a prime. What do you mean by prime numbers? Means prime numbers which have only two factors, that is 1 and itself. That means any number which goes in the table 1 and in the same itself, its table only. That is called prime number. Okay. Move on to the next topic. What do you mean by composite number? Then what is 4 called? It is called composite number. Sorry. Composite number means it's a number having factors more than 2. It can more than 2, maybe 3, 4, anything. That's called composite number. Let's move on to the next topic. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What does this theorem says? Please remember this can be asked in 1 marks question. State fundamental theorem of arithmetic. So here this theorem states like this. Whenever you state a theorem, you should say it in the same way as the theorem is stated. Okay. So the theorem goes like this. Every composite, what it says is, when you find the prime factors for any composite number, the prime factors are unique. Means we get same set of prime factors for number if anyone can solve for prime factors, but the orders may be different. I'll explain the example, then we'll come back to the theorem statement. See, for example, 6, I can find 2 into 6, 3. So factors becomes 2 into 3. Somebody else might start with the 3 table, they will get 3 into 2. So the factors for this composite number remains same, means unique, but ignoring the order of the factors they occur. So every composite number, the theorem goes like this. Every composite number can be expressed as a product of its primes, and this factorization is unique apart from the order in which they occur. They means here factor. I'll read it again. Every composite number can be expressed as a product of its primes, and the factorization is unique apart from the order in which they occur. So this I just explained it. 6 has factors 2 into 3 or 3 into 2. Apart from these two, there's no other factor existing for 6. Okay, that's what it means. We'll go to next topic. Say HCF and LCM. What is HCF? It's called highest common factor. It has another name called GCD. greatest common divisor. Okay. LCM is least common multiple. How do you find HCF LCM for a given set of numbers? That we'll learn here. Okay. We'll start with some examples here. Let us find HCF and LCM of, let's see few example here, 12, 34. Okay. First, find the factors for each of them. Always make sure when HCF and LCM are asked, we have to use the prime factors only for division. 2 6 are 12, 2 3 are. So don't again write 3 1s are. Okay. Therefore, factors for 12 are, you have to write like this: 2 into 2 into 3, then 2 square into 3. We are in 10th standard. Don't just like leave 2 into 2 into 3. You exponent it. Okay. So 34, similar way, 2 7 ja, 17 is a prime. That's it. That 34 is equal to 2 into 7. Before you find HCF and LCM, make sure you get the prime factors properly arranged. Now we can find HCF. What is HCF? How do we get HCF for a given numbers after finding the prime factors? Make sure, please remember these points. You choose the only common factors in the prime factorization of the given numbers. And apart among the common one, choose the least powered factor. Means I'll say 2 here, 2 square is, they're common, but 2 square is bigger than 2. So we choose the least powered common factor, 2. 17 is there here, 17 not there in the 12 factor. 3 is there in the 12 factors list. 3 is not there in the 34 factors list. So HCF is 2 only. I'm repeating again. When you find the HCF, always find the least powered common factors. Least powered means factor with a small, lowest power, and it should be common across the primes. Then LCM should be, it's against the HCF. You count all the factors in both the numbers, or whatever, how many numbers are given, prime list, you count every factor, highest common factor, and also include the non-common factors. For example, see 2 square and 2, they're common. We have to take the highest forward one. And 3 is there, 3 not is there in the 34 list factors. So consider that also. 17 there in 34 prime factors. It's not there in the 12. So you consider. Then you multiply them and give it. That will be your LCM. So this comes to 4 3 is 12 into 17. 12 7 is 84. 200. 12 1 is 12 plus 8 20. So this is the LCM. I'll repeat. How do we get HCF LCM from the list of primes of a given numbers? For HCF, you choose lowest powered common factors and their product. Here we had only one, so we got HCF2. For LCM, you choose non-common factors also along with the highest powered common factors. Their product will give you LCM. As it's a HCF and LCM topic, I'll tell you two things. Please remember this very important points. Remember the points here. HCF, numbers should divide the HCF. Numbers should divide HCF. See, for example, 12 and 34. Sorry, HCF should divide the numbers. HCF should divide the numbers. Means once you find the HCF, make sure this HCF divides the two numbers. In this case, yes. The other point is HCF is always smaller than the given numbers, or equal to the smallest of the given. We'll see this. For example, if you find HCF of 2 and 4, we get HCF is 2. Okay. Example, HCF of 2 and 4 is 2. In this case, HCF is equal to the smallest, right? HCF is equal to the smallest of the given numbers. Similarly, you can make statements for LCM. What is the statement? Else number should divide the LCM. Remember this, number should divide the LCM. Numbers should divide LCM means 12 divides 204, 13 divides 204. Next, LCM is always greater than the given numbers or may be equal to the larger of the given number. For example, if you see LCM of 3 and 2, since it's a co-prime, LCM will be 6 only, product of the numbers. It's greater than the given numbers. In some cases, LCM will be equal to the bigger factor. For example, 2, 4 and 4. What is the LCM is? 8. 2 1 ja, 2 2 ja. Sorry, LCM is 4. So here it is equal to the largest of the given number. Okay. So this is how we find the LCM HCF. We'll take one more examples to find if numbers are 3. 3 numbers are given. How do you find the LCM and HCF? LCM and HCF of, let us see, 8, 32, 24. Okay. So first find factors for 8. 2 4 ja, 2 2 ja, 8 is equal to 2 cube. 32 is 2 16 ja, 2 8 ja, 2 4 ja, 2 2 ja. 32 is equal to 2 to the power 4. 24 factors, 2 12 ja, 2 6 ja, 2 3 ja. Therefore, 24 is equal to 2 cube into 3. Remember, then HCF. I'll repeat. Pick the common factors with lowest form. See, 2 cube is there, 2 4, 4 4 is there, 2 cube is there. So HCF will be 2 cube. What is common? Only 2 is common here in these 3. 3 is not occurring in any of the other factors list. So HCF is, don't leave like this, expand it and write it. Then LCM is equal to, pick the common factors with highest powers. So in the factors 2 cube, 2 4, 2 cube, we get 2 4 as the highest factor. What is not common factor also you pick for LCM. So in the factors list we have only 3 in the 24, we consider that. So 2 to the power 4 is 32 into 3, that is 3 3 is 9, 2 3 is 6. This is the LCM. Understood? Then sometimes will be given in a different form for these HCF and LCM questions. We'll have to find single number, like just prime factorization they'll ask. Okay, see, prime factorization. Find the prime factors for 5005. So answer is just start with 5, 5 1 ja. Okay, then this will go in note 2, note 3, note 5, note 6, let 7, 7 1 ja. Okay, it will go in 7. 7 1 is 7, 3 remaining 30, 7 4 is 28, 7 3 is 21. Therefore, prime factorization is 5 into 7 into 143. Okay. Just finding the prime factorization is very easy. Make sure you know the table properly. Let's find one more prime factorization problem. 3825. So here, just since it's ending with 5, I'll start with 5. 5 6 5 7 ja 38, 35, 32. 5 6 ja, 5 5 ja. Or again start with 5, 5 1 ja, 26, 5 5 ja, 1, 5 3 ja. So 153 will come, 5 plus 3, 8 plus 1, 9, 3 will go, 5 5, 3 5 ja, 3 1 ja. This will go in again 3, 3 1 ja, 3 7 ja, 17 is a prime. So we'll stop here. So 3825 becomes 5 square into 3 square into 17. Make sure you write in the power exponents form. Don't just write 5 into 5 into 3 into 3 into 17. It is a lower class answer. Means it's allowed in the lower classes, not in the 10th standard. Okay. So I hope you know the prime factorization, LCM, HCF finding. We have one more topic to cover. What is that? So what's the relation between HCF, LCM and the numbers? HCF and LCM is equal to product of numbers. Okay. Example, we'll see. We just found let's take this. What is the example? We took 1234, right? And what is HCF? 2, right? 1234, 2. We'll take that only. If LCM is what? HCF is 2. Numbers are 1234. How do you find LCM? Don't start with prime factorization and find it. It's not required. Now we have a relation, we use that. So what do you mean? What is the LCM we get? LCM is product of numbers by HCF. So what is product of numbers? A into B by HCF. Okay. That is 12 into 34 by 2. Right. 12 into 34 by 2. 12 1 ja, 12 6 ja, 6 4 ja 24. 2 carry 6 3 ja 18 plus 2 20. So this is LCM. This is how you find. Same question I'll make HCF question mark and LCM 204. So HCF is A into B by LCM. A into B is 12 into 34 by LCM is 204. 12 1 ja, 12 1 ja 12. 8 remaining, 12 7 ja 84. 17 1 ja, 17 2 ja. So HCF is 2. Same question I made both HCF and LCM unknown things and found it. Okay. In the similar way, you can make, I'll make A S question mark. So LCM and HCF is given. So LCM and HCF is equal to A into B, A equal to LCM and HCF are B. In the single example, I'm explaining all the concepts here, whatever applicable. Okay. LCM is what we got? 204, right? 204, HCF is 2 by B is 34. 2 1 ja, 2 17 ja, 17 1 ja, 17 1 ja 17, 3 remaining 34. 2 17 2 ja. So A equal to 12. See, we got same number. Similarly, we can find B giving A. So this relation is very important relation. Product of LCM and HCF is product of the given numbers. Here, no need of limiting numbers to only 2 count. It can be 3 also. Okay, that's the reason which is said product of numbers. Okay, this actually completes the LCM and HCF part and the first exercise whatever we need. There is one more question in the first exercise. Let's solve that. See, by the prime factorization, what is the usage? Once we know the prime factorization concept, what is its application? Yes, this is the example for that. So, question is check whether 6 to the power n can end with 0 digit for any n becomes natural number. Means, for example, 6 to the power 1, 6, 6 to the power 2, 36, 6 cube is 216. Like that it goes. For any value of n here, can the value of the whole 6 to the power n ends with the digit 0 here? That is the question asked. How do we find? It is based on the some logic of prime factorization only. Solution goes like this. How? See, for any number to end with 0, it should have a factor 5. One of the factors 5, right? For example, if you take 10, 2 into 5, it has a factor 5, 2 into 5. Like that, for any number to end with 0, it should be divisible by, it should have a prime factor. One of the factors 5. It should have a prime factor 5. Remember this, you have to write in this way only, this kind of questions. It's a 2 marks question. How do you find prime factors for 6 to the power n? We cannot find for 6 to the power n, but we can find for 6, right? 2, 3. When make n, n. So just observe the factors of 6. Here we have 2 and 3 are factors. No factor is, factors list as 5 here to make the number end with 0. Therefore, we conclude that, okay, this does not include prime factor 5. Therefore, 6 to the power n cannot end with digit 0 for n become n natural number list. Okay, not negatives. Can you try for similar way 4 to the power n? Can you try for 4 to the power n? Try to prove that, try to solve that whether 4 to the power n ends with 0 digit. Means this 0 in the unit place. Similar way, first two statements remain same. For any number to end with 0, it should have a prime factor 5. But 4 to the power n is nothing but 2 into 2n. So it doesn't have a prime factor 5. So it cannot end, 4 to the power n cannot end with the 0 for any n natural number. Okay. Let us see one more one more exercise question. Explain why 7 into 11 into 13 plus 13, okay, and 7 into 6 into 5 into 4 into 4 into 3 into 2 into 1 plus 5 are composite. We saw what is the composite number. Composite number is a number which has factors more than 2. Okay. So let's consider solution for this is, consider first number 7 into 11 into 13 plus 13. Okay. Here what is common here? 13 is common. Take out that. There are two terms. So 7 into 11 is 77 plus 1, because 13 you have taken 1 times. 13 into 78. The given number, right? It has the factors 13 and 78 other than 1 and itself. Also, we can write 78 has more than 2 factors. You can write, for example, I can say 78 goes in 3 table, right? 3 2s are 3, 6 are 18, 2 1s are 2 13s are, right? So 13 into 3 into 2 into 13. Therefore, since number of factors are more than 2, given number is a composite. Okay. Since the number of factors are more than 2, it's a composite number. Similarly, we can solve for the other given example. Okay. How do we solve this? What is common here? 5 is common. Take out 5 in these two. So remaining is 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay. So upon solving this, we get product of these all will come as 1008 plus 1, 5 into 1009. Since 1009 goes in any other number, just check out. Let's check out 1009 factors. What is that? 1009. 7 1 ja 7. 3 remaining 30. 7 4 ja 28. 2 remaining. No. 30. Or otherwise we can write here. The given number has factors 5 and 1009. Okay. As factors other than 1 and itself. Means composite number is a number which has factors more than 2 is one definition. Other one is if it has a factors other than 1 and itself, then also it's a composite number. That clause it will fall other than 1 itself. Therefore, given is a composite number. Okay. So I hope you understood the LCM, HCF, prime factorization concept, common composite number, and the relation between LCM and HCF. Okay. Go through the video, understand the concept. Thank you.